Welcome back after the break. We looked at map code and coordinates, but now we're going to have a look at vertical exaggeration. But before I'm going to discuss vertical exaggeration is a question, a calculation that you need to do once you got the information from a cross-section. Now let's just quickly look at cross-sections. Unfortunately, the cross-section section is not in your mindset book, but I believe that your teachers did discuss it with you previously. The first time you dealt with cross-sections is in grade 10. Now when we look at a cross-section, it's basically a side profile of a landform or the area that we need to be able to see. Because once we look at a map, we can't determine objects and shapes. For instance, if you look at this area over here, it's a flat area. But if you look at the contour lines as it represents height, what do we have here? We have a mountainous area, especially if we move further down in the map. Over here, this section over here, we have pole granite domes. That's big, massive batholiths that's being exposed to the surface. But we can't determine the shape of it because it's a flat surface, and how we basically determine the shape and what it looks like is using a cross-section. Now when we look at cross-sections, I'm just quickly going to explain it to you quickly, and I'm going to give a reference on here. A cross-section is basically a graph. Now, I'm just going to draw roughly a diagram over here. Let's say, for instance, this is my contour lines. And this contour line is 20 meters high. This one is 40. This one is 60 meters high. And I ask you to construct a cross-section from A to B. Sorry, just want to get my pen ready. This is incorrect. And I'm asking you to construct a cross-section from point A. What's happening over here? I just want to delete this. A cross-section from A to B. Now, the way we represent a cross-section is on a graph. And as you know by now, a graph got two axes, a vertical axis and a horizontal axis. Now, the vertical axis represents the height. The horizontal axis can only be two information sets, and that depending on what map you're going to use. If this cross-section over here was on that topographical map, what will be the horizontal scale? 1 to 50,000. So let's assume this cross-section, this contour lines was on a let's call the map a 1 to 50,000 map. And let's call it Bloemfontein. And I ask you to construct a cross-section from A to B on this 1 to 50,000 map of Bloemfontein. And then you will be provided with graph paper, and what you need to do is your horizontal scale is the 1 to 50,000 map. Now keep this in mind. The examiner will always provide you with the vertical scale. The horizontal scale is the type of map that you use. And what type of maps do we use? We only use two. The 1 to 50,000 map, topographical map, or an orthophoto map, and the scale is 1 to 10,000. The examiner will always provide you with the vertical scale. So I'm going to provide you with the vertical scale, and I'm going to tell you that 1 centimeters represents 20 meters. So the vertical scale is 1 centimeters represents 20 meters. So you're going to take your ruler and you're going to measure every single centimeter that represents 20 meters. And you're going to start with your lowest contour line. and that's 20. Your next centimeter is going to be 40, that's your next contour line. 60, 80. Now let's quickly have a look. This contour line over there is 20, so we're going to make a little dot over there. This contour line over there represents 40 meters. This contour line over there represents 60 meters. Now, you draw the dot where the line cross, where I ask you to draw the cross section from. Now, where does it cross the line over there? 60, situated right there in line of 60. There's 40, situated over there, and then 20 over there, and you connect the dots, and this landform that you see over there is probably much a conical hill. Now, from the cross section, this is where the question of vertical exaggeration comes in. And if we define vertical exaggeration, it tells you by how much the vertical axis, the height, has been stretched out. Because obviously we're using a much smaller scale. So we want to know by how much has it been stretched out, and what do we use the vertical scale? By meters. There's the vertical scale. Now first of all, let's just go and have a look at the definition, the concept, the formula of vertical exaggeration. And if we look at the formula for vertical exaggeration, is the following. Vertical exaggeration equals the vertical scale on top of the horizontal scale. Now, if I ask you to go and calculate the vertical exaggeration on an orthophoto, now keep in mind, the vertical scale will be provided by the examiner. And what is the vertical scale? Let's just quickly go back to our notes. This is the vertical scale over here. It's the vertical axis. The horizontal scale, you need to determine it yourself. And it's very simple. The question is going to state, calculate the vertical exaggeration from the topographical map or from the orthophoto map. Now, there's your first clue. If the question states, calculate the vertical exaggeration from the orthophoto. Now, what did I mention? The vertical scale, I will produce you with the vertical scale. And what is the horizontal scale of a orthophoto? 1 to 10,000. Now, if we quickly have a look, if the question states, calculate the vertical exaggeration on the topographical map, immediately you need to know there's your scale. So what will the question look like eventually? The question will state, calculate the vertical exaggeration for the cross section on the topographical map. Now, grade 12s, there's your first clue. Immediately over here, topographical map. So you already got one piece of your formula. Now, like I've mentioned, the examiner will tell you the following. Use a vertical scale. Just going to use this one over here. 1 centimeters represents 20 meters. Okay, so that's what your question is going to look like. Calculate the vertical exaggeration for the cross section on the topographical map. Now immediately, if you look at your formula states vertical exaggeration equals vertical scale on the horizontal scale. So the only thing that you had to go and do is go and find out if it's on an orthophoto or on a topographical map. In this case, I've given to you it's on a topographical map. And there's the scale. The examiner will always provide you with the scale. Now, what is the vertical scale? 1 centimeter represents 20 meters. But we need to convert it. Because the 1 to 50,000, what does that mean? 1 centimeters represents 50,000 centimeters. So how many centimeters is there in 20 meters? Let's go back to the basics. There's 10 centimeters in 10 centimeters. How many centimeters there in a meter? Now let's start with meters. How many centimeters is there in a meter? There is in 1 meter. There's 1,000 centimeters in 10 meters. Now, how many centimeters are going to be in 20 meter? Because we need to write according to scale. So vertical scale is 1 centimeter represents 20 meters. So am I right if I'm writing this down? 2,000. That's the vertical scale. What's the horizontal scale? It's been provided to you. Topographical map. 1 to 50,000. So 1 to 2,000 divided by 50,000. So what do we need to do? Simple mathematical skills. 1 over 2,000 times 50,000 over 1. And what will happen then? We take the 50,000 divided by 2,000. And then you quickly need to get your calculator out. 50,000 divided by 2,000. That equals 25 times. Now again, grade 12, keep in mind, read your instructions, read your question properly. I'm going to do another one just to make 100% sure that you understand. Now let's assume the cross section was on the orthophoto. And I state, calculate the vertical exaggeration of the cross section. Now keep in mind, let's assume this cross section was on the orthophoto. Use a vertical scale of 1 centimeters represents 10 meters. Now what's the formula? Vertical exaggeration equals vertical scale over horizontal scale. Now I've mentioned that the horizontal scale, the cross section was an orthophoto, so we know that is 1 to 10,000. Now 1 centimeter represents 10 meters. How many centimeters is there in a meter? 100. How many is in a 10 meters? 1,000. Now we need to divide the two with one another. Divide by 1 to 10,000. So 1 over 10,000 times 10,000 to 1. That gives us 10,000 over 1,000. And if we quickly go and calculate it, 10,000 divided by 1,000 equals 10 times. So that cross section has been exaggerated 10 times. I quickly want to go back to the cross section, and our next topic that I want to discuss with you is intervisibility and visibility. Intervisibility means if you are standing at point A, for instance over here, and I'm standing at point B, will we be able to see one another? Now in this case, will we be able to see one another? If that is where A is, situated over there, and this is where B is? No. Why not? Because you follow the contour lines, there's an increase of contour lines, there's a landform in between us. Now, the intervisibility will change. Let's say, for instance, I asked the question, if I'm standing at point X and you are standing at point B, will I be able to see you? Here's point X. You go back to your cross section, and cross X is over there. Yes, I will be able to see you. But there will be no intervisibility between point A and point B. You can just make a cross between it because there's a structural landform in between the two of us. Okay, so we basically looked in today's lesson to coordinates, we looked at map code, and we looked at vertical exaggeration. Please remember with the vertical exaggeration, please read the question carefully. Now you need to go and determine the horizontal scale, and it can either be the 1 to 10,000 or 1 to 50,000, depending on what map you're going to use. The examiner will provide you with the vertical scale. I hope you enjoyed today's lesson, and see you next time around. Cheers.